Hi everybody, this video is going to cover lesson 11.4, which is found on page 67 in your packet, so that's where you can find this. And we're going to be talking about coordinate proofs for parallelograms. What that means is we are going to be tying together some of our algebra together with our geometry. So that's pretty cool. We get to go back and relearn some of the things we did first semester and apply them to what we're learning today. So what we're going to be doing is proving that a quadrilateral is a parallelogram algebraically. That means we're like using equations to prove that this is a parallelogram. And one thing we know about a parallelogram is that opposite sides are parallel. Well, how do you know that algebraically? They have the same slope. So remember, the slope formula is written for you here. So here's our slope formula. We are going to use that formula to find the slope of different sides and then see if they are indeed parallel. So first of all, remember that when we have a coordinate, this is like our x1 and our y1. This is our x2 and our y2. And on this one again, x1, y1, and x2, y2. And so if we go and look at our diagram, the first one that they're asking about is line AB. So line AB is right here, and this is line CD, which is right here. And we need to figure out, are those two parallel to each other? And so we're going to use the slope formula to do that. So I'm going to take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to take 5 minus 3 over 2 minus negative 3. So I'm just taking these numbers, 5 minus 3, y minus y, x minus x. And when I do that and I subtract, 5 minus 3 is 2. 2 minus negative 3 is like 2 plus 3, and that's 5. We're doing the same thing over here. y2 minus y1 is 0 minus 2. x2 minus x1 is 0 minus 5. That comes out to be negative 2 over negative 5. Now, are those the same? Well, actually they are, because remember, the negative divided by a negative comes out to be a positive. So they're both 2/5, and so they have the same slope. So AB is parallel to CD. So I didn't put it in the answer blank, but this 2/5 goes here, and this 2/5 goes here. Okay, so those two are parallel. Well, then the next question is, okay, how about the other two sides? So now we need to look at this side, BC, and this side, AD, and see if those are parallel. So we're going to do the same thing over again. Okay, I always start by marking them, x1, y1, x2, y2, and x1, y1, x2, y2. So I'm going to do my subtraction. y2 minus y1 is 0 minus 3. x2 minus x1 is 0 minus negative 3. So that comes out to be a negative 3 in the numerator, and negative negative makes a positive 3 in the denominator. If I simplify that, it comes out to be negative 1. Okay, let's try the other one. 2 minus 5 in the numerator, that's y minus y, and x sub 2 minus x sub 1, 5 minus 2. Okay, what does that come out to? Well, 2 minus 5 is negative 3. 5 minus 2 is a positive 3. So that, again, simplifies down to negative 1. So they both have a slope of negative 1. So they have the same slope. So that means that they are parallel to each other. So this is parallel to this. So that's how we're going to figure out if things are parallel or not. Or excuse me, if things are a parallelogram or not. And this process starts to get a little bit long, right? So I'm going to save this one for class. And we'll do that together in class. And there's another one on the next page that we can also do in class together, because that's going to make this video too long if we try to do all of them. So let's go now to the last part. How about if it's a rectangle? So a minute ago we were talking about parallelograms. Parallelograms have opposite sides that are congruent, or excuse me, that are parallel. But a rectangle has opposite sides that are parallel, which we just talked about, but it also has one pair that are perpendicular. And that should be both. If just one, it's not a rectangle. It has to be both. So by opposite, I mean one of them is positive, the other one's negative. By reciprocal, That means it's like a fraction, and we turn that fraction upside down. Okay, so let's look at some examples. We need to find the slope of each segment here. And I went ahead and put it on the graph, so you might take a minute right now. Why don't you pause the video and put these where they belong? And then I went ahead and labeled these x, y, x, y, x, y, x, y. And I didn't put the subscripts on there, like the sub 1, the sub 2, because it's going to change each time. So for now, I'm just going to leave it like this. Okay, I also went back in and labeled my points here, which you can do. I don't think you absolutely have to do it, but it just might help to see what's going on. So we're going to start off by finding the slope of PQ. That is this one right here. And so I can go up here to my list, or if it's easier for you, you can do it down here, because you can also count your rise over run. So if you know where you're going, then you can just count your rise over run. If I go my rise over run, I just go 1, 2, and then 1, 2, 3. So this one has a slope of 2/3, which I just counted my rise over run for it. But I could do the subtraction. So 5 minus 3 is 2, and 1 minus -2 is 3. So I could do it that way too. But this is 2/3. Let's go to the next one, QR. All right, QR is right here. And once again, I can either just count my slope or I can do the subtraction. But since it's on a graph, I can just count my slope, my rise over run. So we might write that down. Remember that slope is rise over run, okay? So if I count my rise over run, I go 1, 2, 3, and then -1, 2. So I went up 3 and to the left 2. And if you're not sure about that negative thing, let's go ahead and do that subtraction again. QR is going to be 5 minus 2 over 1 minus 3. And that gives me 3 over -2. So either way is okay to do it. You can do it rise over run, or you can do it subtraction. RS, where is RS? Okay, here's RS, and I like RS because it has that 0, 0 in there, which just makes it easy, doesn't it? So if I do y sub 2 minus y sub 1, I can do 2 minus 0, so this 2 minus this 0, and 3 minus 0. And so that comes out to be 2/3. And again, I could just count rise over run, 1, 2, 1, 2, 3. All right, and then my last one. So I'm looking for PS now, or SP. Doesn't matter which way you go with it. You can call it either way. And so I'm going to subtract 0 minus 3. That's my y's. And 0 minus -2. That's my x's. That comes out to be -3 and a +2. Remember, negative minus negative is positive. 2 negatives in a row makes positive. All right, so look. We have 2 that are the same. And then we have another 2 that are similar, but they're not the same. So we have a -3 over 2 and a -3 over 2. That means that SP and QR are parallel to each other. Let's look at it. SP is here. QR is here. Yep, those are parallel. Good. Then remember, the other one that we want to look for is the opposite reciprocal. Opposite reciprocal means that, I'm going to show you again, it's up here, that one's positive, the other one's negative, and they're upside down from each other. Okay, so here's a 2/3, and here's a 3 over -2. One's positive, one's negative, and they're upside down. So QR and PQ are perpendicular to each other. QR and PQ are perpendicular. We have another 2/3 over here, so 2/3 is perpendicular to this one. It's also perpendicular to this one. Okay, so that was RS with QR. Here's RS, here is QR, and that was RS with SP. Here's RS, here's SP. How about this one over here? Was it? Well, that was SP and PQ. Here's SP, here is PQ. Yep, those are perpendicular. And notice these also are parallel to each other. So we've got a lot going on. We've got all the things that we need for a rectangle. Okay, so that is how we prove if things are parallelograms or rectangles. We use the slope formula, rise over run, or y sub 2 minus y sub 1 over x sub 2 over x1. We will do those ones that we skipped. We'll do those in class.